welcomes you to VC Tech Education. Today I am going to discuss related to the disk scheduling algorithm as part of operating system. The disk scheduling algorithms are mainly FCFS, that is first come first serve scheduling algorithm, whereas the next is SSTF, which means shortest seek time first scheduling algorithm, scan scheduling algorithm, cscan disk scheduling algorithm, look scheduling algorithm. So these are the major algorithms which we are going to discuss as part of disk scheduling algorithms. When in previous session we discussed about the hard disk drive and tracks, sectors and clusters. So here once again I am going to discuss related to it. Here you can see the hard disk. The hard disk drive will have the sectors, tracks, and all these the round circles comes under the tracks and the divisions comes under the sectors, and a small block. Here you can find them as a block. So these are the different parts which we even discussed in the previous session. The next thing is about the hard disk structure, where the hard disk is of a cylindrical structure with arm positions of called cylinders, where it comes under a set of tracks, and each track is subdivided into sectors. Each track is divided into sectors, and where we are going to have the data in a particular blocks. So this is the diagrammatic representation of a disk structure, where a hard disk is a collection of platters. Each disk platter has a flat circular shape called compact disks, and disk will be of the diameter 1.8 to 5.25 inches, whereas on these disks there will be a circular tracks. On circular tracks are subdivided into sectors, and on the sectors you will find the blocks. On blocks you are going to store the data will be stored. The storage capacity of a common disk drive is measured in the gigabytes. So this is all about the data disk structure. Then the performance of a disk. The disk performance will be identified with the seek time. That means how much it takes to identify the data that comes under the seek time. So you can observe here the seek time. The time it takes to position the head of the desired track is called seek time. So see here, you can see a head which is moving to track on the, this is the head which is moving to track on the disk. So here first it will go to the, most drives rotate in 60 to 150 per second, and it will go to the head position, starting position, and from that particular position it will track. That comes under the seek time. So here we are going to identify the seek time. The problems related to the disk scheduling is algorithms related to the disk scheduling is majorly based on the seek time. So here once the track is selected, the disk controller waits until desired sector reaches to read write head. So the time it takes the desired sector is called the latency time or the rotatory delay. The sum of the seek time and the rotatory delay is the access time. So to identify the access time, it depends upon the rotatory delay as well as the seek time. So these two are the major concerns related to the access time. When the desired sector reached the read-write head, then the particular real data transferring will start. Next, related to the seek time. The time required to reach the desired track of the read-write head is called the seek time. The seek time consists of two key components: the internal startup time and the time taken to traverse the cylinders that have to cross it once the access arm is up to speed. The linear formula of peak time is EST equal to m into n plus s. EST stands for estimated seek time. M stands for constant that depends on the disk drive. N stands for number of tracks traversed. S stands for the seek time. Then comes to the rotatory delay. The time required to reach the desired sector by read-write head is called rotatory delay. Generally, the average rotatory delay will be between 100 to 200 meters seconds. Then comes to the transfer time. The transfer time is depending on the rotatory speed of the disk. The formula for the transfer time is T equal to B by N into N. T equal to transfer rate, B equal to number of bytes to be transferred, N equal to number of bytes on the track, R equal to rotatory speed in revolutions per second. Thus, the total average access time can be expressed as AST, that means average seek time plus 1 by 2 R plus B by Rn. Rn means rotatory, N for the number of rotation speed, R stands for the rotation speed in revolution per second, N stands for the number of bytes on track. So TAT stands for the total average access time. So this is all about the transfer time. So next is the first come first serve scheduling algorithm. This is the disk scheduling algorithm which says that first come will be served first. It is the simplest disk scheduling algorithm of all, but it does not provide the fastest service. Let's take an example. Consider an example a disk queue with request for input output to block on cylinders. That is 87, 170, 40, 150, 36, 72, 66, 15. The head starts at 60. So generally the head which starts from the 60. In this order, if the head starts initially at 60, so the circular cylinder, the head will start at the 60. It will first move to the 60 to 87. Okay, let's check this problem. So this is the problem. Consider for example a sequence queue with the request of input output block of cylinders 87, 170, 40, 150, 36, 72, 66 and 15. The head starts at 60. So the head will starts from here. From where the head will start? It will start at 60. In this order, the first head is initially at a cylinder 60. It will move to 60 to 60 to 87. Then from 87 to 150. Then 87 to 170. Then 170 to 40, 40 to 150, 150 to 36, 36 to 72, 72 to 66, 66 to 15. Let us see this. So the next step will be the 87. So the disk, here we are 60, 60 to 87. Okay, 60 to 87. This is the first diagram line. The path will move from 60 to 87. So here it is, the value is 87. Then 87 to 170. So from 87, here it is the 170. So parallel to here I am giving a mark. For 87 to, it go up to 170. So first is at 60 and 60 to 87, 87 to 170 and 172 again it will go back to 40. Why this is like this? Since we are going in first come first serve. After 60 is the starting point. Who came first? 87. So 87. After 87 who came? 170. So 170. From 170 again we came to the 40 and 42 again here it is 150. So 42 again 150. What is here? It is 40 and here it is 150. So here from 60 to 87, 87 to 170, 170 to 40, 40 to 150 and 150 to again 36. 36 from 170 to 36 and again from 36 to 72 and 36 to 72 and from 72 to 66 again back here 66 and from 66 to 15. Okay, 66 to here it's 15. So this is about the first come first serve. Since the head starts at 60, the next first comes is the 87. We went from 60 to 87. From there we went from 170, 170 to 40, 40 to 150, 150 to 36, 36 to 77, 77 to 16, 16 to 15. So in this order, the head is initially at cylinder is 60. It will first move to 60 to 87. It will move from 60 to 87, then from 87 to 170, 170 to 40, 40 to 150, and 150 to 36, 36 to 72, 72 to 66, 66 to 15. So here, then we are going to calculate the total head movement. From 87 where it moved to from 60 it moved to 87. So 87 is the biggest number. So I am taking 87 minus 60. So the value is 27. Then comes to 170 to minus 87. The value is 83. Then 170 minus 40. The value is 130. Then 150 minus 40. The value is 110. Then comes to 150 minus 36. The value is 114. Then comes to 72 minus 36. The value is 36. 72 minus 66, the value is 6. Then 66 minus 15, the value is 51. The total head movement of the cylinder is the 557. Then the average head movement equal to 557 divided by 8. Why 8? 1, 2, 3, 4, 5, 6, 7, 8. So 87 to 15, there are 8 movements, so divided by 8, so the average head movement is 69.6. So once again you see the diagram, you will get this as an diagram where it will indicate the first come first serve scheduling algorithm. So the disk is at the head is movement is at 60, 60 to 87, 87 to 170, 170 to 40, 40 to 150, 150 to 36, 36 to 72, 72 to 66, 66 to 15. So this is all about the disk scheduling algorithm related to first come first serve scheduling. Next comes to the SSTF, which means that the shortest seek time first. So here it is the shortest seek time first. The algorithm selects the request with minimum seek time. What it will do, it will select the with the minimum seek time from the current head position. So from where it will get from the current head position. Consider for the example the disk queue with respect to the input output block on the cylinders. So where these cylinders will be identified, 87, 170, 40, 150, 72 and 15, as it will starts at the 60. So here it starts the position at 60, and where it will go to the shortest. Okay, it will go to the shortest. Shortest distance. So nearby 60, what is the value we have? 66 is the nearby to the 60. So it will go to the 66, and from 66 nearby is the 72, and from 72 nearby is the 87, and from 87 the then 40, 36 and 15. The remaining numbers are 150 and 170, whereas 150 then 170. So it will check the nearest movement for the head and then it will move. Let us check the problem. Consider for example a shortest queue with a request for input output to the block on the cylinder 87, 170, 40, 150, 36, 72, 16 and 15. The head starts at 60. Where the head will start? It will start at 60. Okay, the head starts at 60 and then it will move to the nearest one, that is the 66. So let's imagine 66 will be here. So that it will move to 66. Then it will go to the 72. So here 72. So 60, 66 and 72. Then comes to the near to the 72 is the 87. Then it will go to 87. Then from 87 the next nearest is the 40, which will travel to the opposite side. And this is the 40. Okay, it will travel to 40 and from 40 to next is the 36. Then from 36 the next is the 15. Then after 15 the next is the 150. So here we are in okay, from here 15 we have to go to 150. And from 150 we have to go to 170. So this is the diagram which we got. That is, we traveled with respect to the shortest distance. So here the total head movement is 66 minus 60. 72 minus 66, 87 minus 72, 87 minus 40, 40 minus 36, 36 minus 15, 150 minus 15, 170 minus 150. So the head moment is 6 plus 6 plus 15 plus 47 plus 4 plus 21 plus 135 plus 20 equal to 254 cylinders. The average head moment equal to 254 by 8 equal to 31.75. So this is the diagram which we received by using the SSTF. Next comes to the scan scheduling. The scan scheduling algorithm is also called as elevator algorithm. The scan scheduling is called as the elevator algorithm. See here, this works as a one direction. See, when you go for a Xerox center, it will scan the image in the Xerox. The light will travel from one end to the another end. So here the same thing, it will travel from one end to the another end. So in this algorithm, the disk arm starts at one end and moves towards to the another end, while in meantime all the requests or servicing using its gets another end on the disk. Let's take an example, the same example, that is, consider for an example a disk queue with respect for input output to block on cylinders 87, 170, 40, 150, 36, 72, 66, 15, where the head starts at 60. In that order, if the disk head is initially at a cylinder 60, it will first move from 60 to 66, then 66 to 72, then 72 to 87, then 87 to 150, then 150 to 170, then 170 to 200. At disk at the cylinder 200, the arm will reverse and will move towards the other end of the disk. Then 200 to 36 and 36 to the 15. Let us check the example. So as per the scan scheduling, we will start at 60 and we will go up to the end of the thing, that is up to 200. Let's start the journey. Here we are starting at 60 and we are moving towards the 66. The first nearest value is the 66. So here we are moving. Then from 66 the nearest value is the 72. Then from 72 the nearest value is the 87. And towards that the next value is the 150, same direction. Then from 150 the next value is the 170. And from 170 we have to go back. So as per the scan scheduling, we should go up to the end. We should go up to the end. So we will go up to 200. As per the scan scheduling, we will move up to 200. And from 200 we have to come back. Okay, we have to come back. That is, whatever is completed, we have to check it off. So 86 is completed, 66 is completed, 72 is completed, 87 is completed, then 170 is completed, 150 is completed. The remaining terms are 40, 36 and 15. So next is we will move towards back and we will go up to 40. And from 40, this is 40. From 40 we are going to 36. And from 36 we are going to 15. By this we end the concept. So here the concept is, consider for example a disk queue with respect to input output block 87, 70, 40, 150, 36, 72, 15, whereas this is a scan scheduling. So So the moment of the head will be calculated as 66 minus 60, 72 minus 66, 87 minus 72, 150 minus 87, 170 minus 150, 200 minus 170, 200 minus 36, 36 minus 15. The total head moment is 6 plus 6 plus 15 plus 63 plus 20 plus 30 plus 164 plus 21, that is 304 cylinders. The average head moment equal to 557 by 8 equal to 38 cylinders. The main drawback in the next scheduling algorithm is the C-scan scheduling algorithm. So when you compare with the scan scheduling algorithm, the main disadvantage of scan scheduling algorithm is the waiting time is not uniform. So some requests the waiting time is much time. So some requests of servicing immediately. To overcome this particular drawback with the C-scan, overcome with drawback, the C-scan is introduced, that is the circular scan. C-scan scheduling is designed to provide a uniform wait time. In this algorithm moves the head from one end to another end of the disk, servicing the request along the way. When the head reaches the other end, it immediately returns to the beginning of the disk. So it will reduce the wait time. To reduce the wait time, the pointer will move, returns to the begin of the disk. So the pointer will return to the begin of the disk without servicing any request on the return trip. The algorithm treats the cylinder as a circular list. So next, let's take an example problem, the same problem with the disk queue with respect to input output to block the cylinders 87, 170, 40, 150, 36, 72, 16, 15, where the head starts at 60. In that order, if the disk head is initially at cylinder 60, it will first move from 60 to 66, then 66 to 72, 87 to 150, 150 to 170, 170 to 200, then 200 to 0, and then 0 to 15, and then 15 to 36, and then 36 to 40. Let's check it with the example. So as per the C-scan, it will not wait and it will go immediately after going to one end. So now we are starting our journey as usual at the point 60, and from 60 we will go to up to 66, and from 66 we are going up to 72, and from 72 we are going up to 87, and from 87 we are going up to 150. From 87 we are going up to 150, and from 150 we are going up to 170. So 150 we are going up to 170, and from 170 we are going to the end point, that is 200. So from here we are going up to 200, and from 200 we straight away go back. We'll go back to the starting position, this end, from that end to this end, and that from 0 we are going to 15. Okay, then from 15 to again 36, and from 36 we are going to 40. So this is the diagram which we are going to get with this particular C-scan. So here, after coming here 170 to 200, there is no wait time. Directly it will go back to the 0th position, and from there it will going to the selected areas. So the total head moment is 66 minus 60, then 72 minus 66 plus 150 minus 87 plus 170 minus 150 plus 200 minus 170 plus 200 minus 0, 15 minus 0, 36 minus 15 plus 60 minus 36. Then the total head moment equal to 6 plus 6 plus 63 plus 20 plus 30 plus 200 plus 15 plus 21 plus 4, that is overall 365. Then the average head moment equal to 365 by 8, it is 45 point something. Then the last one is the look scheduling. The previous algorithms, that is C-scan and the scan, the disk arm across the full width of the disk. But this algorithm arm does not as far as the final request each direction. So it will not go up to the end, it will go up to the each direction only. Then it reverses the direction immediately without reach the end of the disk. Consider an example with the same example, that is 87, 170, 40, 150, 36, 72, 66 and 50. The head starts at 60. In this particular order, it starts at its journey at 60 and then moves to the 66, 62 6 to 72, 72 to 87, 87 to 150, 150 to 170 and 170 to 15. Let's do it. So it starts its journey at 66, 60 and 60 to 66, 62, 6 to 72, 72 to 87, 87 to, after 87 the next is the 150. So where we are at 87, from 87 to 150 and from 150 to 170, 150 to 170, 170 to 15, 170 to 15, 15 to 15 to 36, 36 to 40. Okay, so this is about the look scheduling. So the look scheduling, the moment is 66 minus 60, 72 minus 66, 87 minus 72, 150 minus 87, 170 minus 50, 170 minus 15, 36 minus 15, 40 minus 36. So the total head moment is 6 plus 6 plus 15 plus 63 plus 20 plus 155 plus 21 plus 4, that is 290 cylinders. So 290 by 8 equal to 36 some change. So these all are the different scheduling algorithms which we discussed right now, and hope you all understood well. That is the FCFS scheduling algorithm, then SSTF disk scheduling algorithm, scan scheduling algorithm, C-scan scheduling algorithm and look scheduling algorithm. Hope you all understood well. Thank you very much.